Hey everyone. In this video, I'm going to show you a step-by-step walkthrough to set up your own research design and analyze it using the declare design package in R. And to do this, to showcase the functionality of the package, I'm just going to use some of my own work, which is a co-authored study that we conducted in the summer of 2020, focusing on the relationship between partisanship and accountability or perceived accountability of the government, US government, in handling the COVID-19 pandemic. Specifically, the setup of this study is that there was a survey that was fielded in July 2019 with 1,500 US adults by YouGov, and we were able to add some questions on this. This was in collaboration with Jana Krupnikov and John Ryan at Stony Brook University. And the study or the survey existed, and there was room for some questions, and we added some questions on specifically the handling or accountability in handling COVID-19. Okay, so in contrast, and kind of going back to what I mentioned in the previous videos, in contrast to kind of the conventional power analysis, where we're looking at an assumed effect size and we're trying to estimate the necessary sample size to basically identify that effect. We have a different setup here where we have a set sample size that is given and that we cannot change, and we want to explore under different, or the goal was to explore under different assignment, treatment assignment regimes and different designs to examine the power, statistical power under different assumed effect sizes, right? So the setup is a slightly different one, but you can adjust it, if you're interested in, computing necessary sample sizes, you can easily adjust the code that I'm showing you here. But the setup is kind of a slight deviation from this traditional or conventional power analysis where the goal is to estimate the required sample size, right? The idea behind this survey experiment is relatively simple. We're interested in how partisanship affects perceived accountability of the Trump administration to handle COVID-19, right? And in the context or during the time when this study was fielded, which was in early July, end of June 2020, and I just realized that it says 2019 here. I will of course correct that it was of course this year, 2020, during the COVID pandemic. Okay, the context was this was shortly after the height of the first wave in the United States, and you could already see based on cases, overall cases, that the US had a much higher caseload than other European countries. But if you look at certain statistics like deaths per capita, the US was actually doing not too poorly compared to some other countries. Some European countries were hit much harder early on, had higher deaths per capita, and therefore in comparison at that time the US was not doing so poorly, right? So we wanted to leverage this variation by framing the performance of the US government in handling COVID-19 by showing different comparisons with other countries. Specifically, we have three different conditions. In one condition, this is the favorable framing of the administration's handling of COVID-19, which is, these are all based on actual real statistics on COVID deaths per million people, so per capita. And you can see the red line is always the United States. You see the overtime change of total confirmed deaths due to COVID-19 per million people, as I mentioned. And you can see that, of course, deaths were rising in the United States, but if you compare it to Spain, which was hit much harder early on in the year, or earlier on, in March and April, death rates were much higher in Spain, right? So viewing that information kind of puts the U.S. performance at that time, or the performance of the U.S. administration at that time in a more positive light. Compared to on the right side here, we have the comparison to Germany, where of course deaths per million were much lower, continue to be much lower, and so this is a comparison that emphasizes that the U.S. was doing poorly compared to a European partner, and that is comparable in wealth and other characteristics, right? So we have one kind of negative comparison, one positive comparison. Of course, by now, now by the end of the year, this comparison looks much worse, but at least at that time, for the US, this was relatively favorable. We have a control condition that is basically a combination of the two, that shows, of course, the line for the United States, but basically combines Spain and Germany, and basically shows, okay, there are countries that were doing better, there were countries that were doing worse in late June, early July. So based on this framework, based on this experiment with three different or two different treatment conditions and one control condition in the center, we have three main hypotheses. The design was a little bit, there were other components to the design. We're not going to look at those here. For the purpose of this illustration, we're only looking at this simplified framework, right? I'm going to move myself up here for a second. And then continue the hypotheses. The first hypothesis is Republicans will be motivated to disregard information that suggests that America has underperformed relative to other countries on certain dimensions of addressing COVID-19. Second hypothesis, kind of equivalently, Democrats will be motivated to disregard information that suggests that America has outperformed other countries on certain dimensions of addressing COVID-19. And thirdly, the effects of H1 and H2 will be most pronounced among strong partisans relative to weaker partisans. And I should say, in the context of the power analysis that I'm going to present now, we will just focus on hypotheses 1 and 2, and we will disregard hypothesis 3 for the purpose of this illustration. Okay. So the main point is, of course, we have a control condition. Compared to the control condition, people who receive the positive kind of framing should have a more favorable assessment of the government's performance, but according to hypothesis 2, this should not be the case for Democrats, who will be motivated to disregard that information. On the other hand, the negative framing, so this negative comparison of the US government's performance, should lead to a less favorable rating of the government's handling of the COVID-19 pandemic. But according to hypothesis 1, this should not apply to Republicans. They should disregard that information, right? So basically that's the whole setup of how partisanship interacts with these treatments. Okay. Now in the following in the remainder of the video, I'm going to show you how we can kind of translate this basic setup into or kind of set this up in declared design and analyze the design's properties with regard to power, but we could also examine bias or type M error and type S error and the like. It would be straightforward to do so. Okay. The first thing we have to do, even before we start setting this up in R using the declared design package, is to think theoretically about the underlying data generating process and the estimation strategy, and kind of set that up, right? And again, as I mentioned early on, the question here is a slightly different one than the conventional power analysis, where the conventional power analysis focuses on estimating the necessary sample size to achieve a certain level of power given an assumed effect size. Our question here was a little bit different because we had a given sample size that we couldn't deviate from. And the question was, given a fixed sample size of 1500, how strong does the treatment effect need to be in order to detect partisan motivated reasoning with sufficient statistical power, so 80% statistical power, okay? And ultimately in the planning process, we did this prior to running the study and compared different types of treatment assignments and different types of designs ultimately to kind of maximize power given assumed effect sizes and kind of features of the design, right? So how do we set this up? In the example that I'm going to show you here, we will assume a certain data generating process. Okay, and this is just the assumed relationship between the variables kind of in the population, and that we're trying to make inferences about. Okay, the way this is set up is our outcome variable is some continuous measure of how people evaluate the government's performance in handling COVID-19. Positive values indicate that the government was handling the pandemic well. Negative or lower values indicate that they were handled poorly. Okay, and just in the beginning, since we're not really interested in the effect of partisanship itself, for now we can just for simplicity assume that Democrats on this kind of scale of government evaluation suppose that independents have an average evaluation of 0. Democrats have an average evaluation, or the evaluation among Democrats is -1, and the evaluation among Republicans of the government's performance in expectation is +1. Okay, so we just kind of assume that as the basic baseline of the variation that we see in the underlying data, right? Or in this outcome variable, right? So it ranges in expectation from -1 for Democrats to 0 for independents to +1 for Republicans. And again, we're not looking at strong and weak partisans here because we're just looking at the kind of simplified case. Okay. And then we have our treatment. We have our treatment that is negative and positive. Again, this is compared to the control condition where we show both the negative and positive kind of comparison combined, right? And for simplicity, we're assuming that the effect of the positive treatment and the negative treatment, or the positive framing and the negative framing, are equal in size. One is of course negative. This is minus gamma times negative. That's the indicator for being in the negative treatment condition versus the control condition. And we have plus gamma times positive, so that's the indicator to be in the positive treatment condition, and this is the effect of the gamma is the effect of the positive treatment as compared to the control condition, right? So this assumption that this is kind of symmetric in terms of negative and positive effects is a simplifying assumption, but we don't really lose any generality, since we will ultimately examine power under different effect sizes. That'll be the main task, right? And so as you can see here, the treatment has, the negative treatment is assumed to have a negative effect, the positive treatment is assumed to have a positive effect, and now the question is, how large is this effect? And what we're going to look at is a range of possible effects, where gamma will range from 0.1, so it's very small, to up to 1, right? And so kind of to think about why we chose this, think about this in relation to the effect of the of partisanship, right? So at the maximum of assumed effect size, which is of course probably too large, or larger than we would realistically assume, the effect would be 1 for +1 for the positive treatment and -1 for the negative treatment, which would basically imply that independents who receive the positive treatment evaluate the Trump administration just as positive as Republicans in the control group. Or in other words, focusing on Democrats who receive the negative treatment, independents who receive the negative treatment with gamma equal 1 would evaluate the Trump administration's handling of the COVID pandemic just as negative as Democrats who were in the control group who just received the neutral treatment, right? So that's the basic setup. Of course, it doesn't end here. We have additional components. We have an interaction between the negative treatment and Republicans, which is gamma times negative times Republican. And the idea here is, remember, hypothesis 1 stated that Republicans will disregard the negative information. They will not be affected by that negative information. So in order to model that, that means that the negative effect that we initially kind of suggested for the negative framing, the effect of the negative framing, we have this is completely washed out among Republicans, right? So only independents and Democrats are actually affected by this negative framing. Republicans, for Republicans, this cancels out, basically. That's the assumption, okay? Equivalently, this is down here, we have the same pattern for Democrats, right? Democrats who receive yes, so Democrats, exactly. Sorry, I was confused for a second, but Democrats who receive the positive treatment, they will not be affected. They disregard this positive information about the Trump administration's handling of the pandemic. And so this minus gamma times positive times Democrat means that this positive effect of the framing treatment will be basically canceled out among Democrats. It will only have an effect among Republicans and among independents, okay? And then in addition, we have two additional parameters that are not really central to our key question of interest, but these are the basically the interaction of the kind of crossed negative treatment and Democrats and positive treatment for Republicans, right? So the question here is, to what extent is the effect of the negative treatment among Democrats stronger or less strong than among independents, and likewise for Republicans as compared to Republicans who receive the positive treatment as compared to independents. And we set this up with a 1/2 gamma as the interaction and negative 1/2 gamma. The idea here is that we basically just assume that there is a ceiling effect, right? So that means that independents who receive the negative treatment should have the full effect of minus gamma compared to the control condition. For Democrats, since they already have a negative evaluation of the Trump administration anyhow, this negative effect will be slightly slightly reduced due to ceiling effects, right? Similarly, for Republicans, people who identify as Republicans already have a positive evaluation of the Trump administration. So in the case where they're assigned to the positive framing condition, the effect of that frame will be slightly reduced in the sense that there's a ceiling effect and they will not be, even more positive towards the Trump administration. Of course, this is, you could think of this as a strong assumption that this is a ceiling effect of like 0.5, but the key here is also that these interaction terms are essentially not central to the hypothesis that we're interested in. The main interest is basically the interaction between the negative treatment and Republicans and the positive treatment and Democrats to look at this partisan motivated reasoning effect. And the question is, how strong does the treatment overall have to be in order to identify this motivated reasoning or this washing out of the treatment among Democrats and Republicans for positive and negative treatments respectively, okay? So in order to do this, we will set up this data generating process in declare design, and we will ultimately vary gamma across a range of scenarios to explore statistical power under different assumed effect sizes. And again, you can think of them as relative to the partisan differences that we observe prior, like pre-treatment in the sense, right? And we will range gamma from around 0.1 to up to 1. So the maximum effect size that we're going to explore is equivalent to the pre-treatment partisan differences, which is assumed, which is a quite substantial effect size. Okay. Then our kind of estimation strategy, we will basically estimate these treatment effects of interest using a basic linear regression model that is kind of equivalent to the model specification that I laid out up here, where we basically estimate individual coefficients for each of those dummy indicators and interactions, and then compare them to our actual data generating process. And based on that comparison, we will be able to assess power, bias, type M error, type S error, and so on. Okay, so that's the basic framework. Of course, and I mentioned this before, the setting up this data generating process and this estimation strategy involves a lot of kind of simplifications and assumptions. And of course, our model might be misspecified. Our data generating process might not be completely accurate. Or might not completely capture the functional relationships between those variables, or there might be other confounding factors. But this is at least a starting point to examine the effect of certain design choices on our statistical power and on other characteristics of our estimators. Okay. So after kind of going through the first step and setting this up, I'm going to take a quick break here, and then in the next video kind of dive into how to set up this framework in Declare Design.